Earlier on the year, I become addicted, like many people, to using the interface. So I started falling down a rabbit hole, and now I know slightly more than I did at the start of the year, but there's still a lot to learn. And in fact, there's so much changing in this space every single week that it's honestly hard to keep up. Yeah, Ben Young, work for a cloud service provider in New Zealand called SoftSource vBridge, but by night, this is what I do and I have fun with. So yeah, falling down a rabbit hole. So what are my goals? I wanted to learn a bunch of new things, kind of a lifetime learner, love learning about new technology. I wanted to build a chatbot web interface for something. And in particular, I've built it across the Veeam knowledge base articles. So we've, in IT, we're used to consuming these knowledge base articles. Sometimes we've got to read them, they're this long. And so, hey, it would be nice if we could chat to these things. And so that's where I landed with this kind of idea. Because it was easy and consumable and relatively cheap, I decided to use the OpenAI models, but let's face it, there's lots now available, open source ones. You can even run them on your laptop and things now. They're getting better. I wanted to learn about vector embeddings. As you'll see, it's a very important piece to the puzzle, and as well as vector databases. Okay, as industry professionals, we're used to dealing with databases. Yeah. These are just a regular database in a way, but they are optimized to kind of work with this sort of data set that we're talking about. And have fun, share the knowledge, and iterate on it. So here we are. So we'll set the stage. We'll run through some of the building blocks, and then at the end, I'll show you a demo, and it was working 5 minutes ago, so I'm assuming it's still going to work. So retrieval augmented generation, otherwise known as RAG, if you see this floating about on the Twitters or the Mastodons or whatever. This is kind of what we're using to do this. And why it's important is, as Gina was saying about these large language models, they were trained to a point in time where we're kind of stuck in a model. They scraped the internet, they consumed all these things, and the model was trained at great cost to the environment by the look of it. But it's stuck in time. So a new KB article, hundreds of KB articles have probably come out since then. Plus, it's just all bundled in with the rest of the noise on the internet. And so this is where this retrieval augmented generation comes in. We can pass it additional context and then use the power of the chat model itself. It understands language and how to structure things. And if I want to get it to talk like a pirate, I can, because it understands all those things. And so what we do is we pass that along with it. And so, yeah, why we don't use the large language model just on itself is it's not trained on private data sets in particular. Obviously, the Veeam KB articles are public, so that it's probably in there somewhere. But if we want to start using our private data, some private data sets that reside within our SharePoint or file systems or wherever it might be, it doesn't really know about those. And there's obviously some things to cross there. And it's costly and timely to retrain these LLMs. As we've seen, it uses a lot of compute horsepower, particularly from NVIDIA, a lot of time, a lot of money to train these big models up. Why I didn't fine-tune, I didn't have enough time to go and build out a bunch of fine-tuning data, so this was just an easy way for me to pass it. Plus, fine-tuning comes at a cost as well, apart from just the cost to actually train and retrain and host your own large language model. OpenAI can now support that via their APIs too, which is pretty neat. But it's difficult to prevent hallucinations and a bunch of other things. So I went down the kind of the RAG method. So what does that look like in practicalities? Starting out to the left there, you've got your question. So that's a user typing in a prompt, right? There I am there. What we do is our smart retriever, our code, will reach down into our external data set. Now that could be whatever that is. You've got code that can handle multiple different sources of data now. We'll talk about my source in a second. It then retrieves the relevant documents or document that we want. We then pass those documents in a nice format along with our question to the LLM, and then we let it interpret that. And it's no different to you copying an email from someone, pasting it and go summarize this. It's kind of like that, but it's automating that process. The LLM computes it, spits us back the answer, and we're all happy. So that's kind of it in a nutshell. So the data set itself, obviously, it had some challenges. The Veeam KB articles, they look great, very consumable on the internet, but there's a lot of other embedded forms and messy data that we don't necessarily want to put into our prompting because that's an additional cost. The more tokens we're passing into OpenAI, the higher cost it's going to be. Plus, we don't want it to get distracted with information that it doesn't need to know about. There was no simple index page to get the KB numbers, so I had to get around that issue. There's no programmatic access, so I had to get around that issue. And we've talked about the inline content. So how I solved it was a bit of code. Basically goes out and scrapes the Veeam KB website, converts it to Markdown format, so strips out all the HTML, all the embedded styles and extra div tags and things that we just don't need, gets it into Markdown format, and then I can start working with it. Stored it in a local MongoDB database, so I've got access to it. And then for the community, I actually wrapped an API over top of that, so not only I can consume it, but anyone else that wanted to programmatically get these these KB articles, they could just hit my API and know that there's a programmatic way to receive the KB information. And then there's obviously a regular background process to go and check for new ones in the nicest way. So here's what your typical KB article looks like. You can see the big red boxes are stuff that I've kind of removed. There's a print icon, not relevant. Get weekly updates, don't care about that. This big red box at the bottom is real messy. There's an inline form and a bunch of things in there. And then the points 1, 2, 3, 4 is really interesting because one thing I wanted to do in the future iterations of this is work out what parts of the document I'm talking with. So I'm cleaning up the whole document and storing that, but I'm also storing challenge, cause, solution, more information, and there's a bunch of other kind of sections that are commonly used across the KB articles. So at any point in time, I can just return a part of the article without having to kind of magically work that out. So this is what we want it to look like. So this is after an article's been cleaned. You can see on the left-hand side the raw markdown that I've just pasted into an editor there. That's kind of after I've cleaned everything up. That's the sort of data that we're going to be passing to our LLM. And then on the right is it actually rendered back into kind of an HTML form from Markdown. So you can see it's much cleaner than that kind of web page that we were dealing with. Here it is in the database. So you can see here's all the sections around the details, solution and cause and a bunch of other things. And like I said, I've got the full database there as well. And here's the API. So I can use this. I'm obviously using the get one in particular quite heavily, as you'll see in the demo, but I can also create new ones, delete things as I need to. And as I mentioned, this is a public API, so anyone can actually hit this API and use it internally if they wanted to. And this is kind of your typical response that I'm getting back for when I query that out of the database itself. So, embeddings. Basically, ML models like to work with numbers. And what embeddings does is it takes some text. So this is an example that OpenAI give on their website. Very short version. We're obviously feeding in that whole document. What it does through an embedding model, very fast, very cheap operation, it'll create a big array of vectors, 1,536 of them to be precise. That is effectively the numerical kind of calculation, if you like, of that text. The nice thing is, embeddings that are numerically similar are also semantically similar, which is important when we are looking up the database in a minute for things that match our query, perhaps. And OpenAI, I've got one, but there's tons of open source models, lots of other semi-commercial models that you can consume as well. And all we have to do is pass the text in and we get basically that array back. And then this is kind of, again, from OpenAI, but it's a nice way of representing things that might be semantically similar or related. So you've got a quarterback throws a football down in vector space, kind of down the bottom left there, but then you've got everything kind of related to sort of animals and whatnot up the top right. So you can imagine once we start building up a huge bunch of vector space, we can start querying in space where those things are and pull them out. And that's kind of what it looks like. So this is the query response back from OpenAI. You can see there's a bunch missing in the middle, but we get 1,536 of those little pink numbers back. And that's what we store in the database, along with some of the metadata, such as the source, what the KB number was, when it was embedded, when it was last updated, so that we can refresh things in an optimal way. This particular model is the ADA 002 model from OpenAI. So then we need someone to store them. We've just gone and scraped all these 2,400 odd KB articles. We've embedded them. Now we need someone to store them, because otherwise every time that we open up our chat model, we have to go and re-embed those on the fly and then store them in memory, and then that's just inefficient and costly over time. So we need somewhere to store it, and there's lots of options. This space is changing a lot. There's been a lot of funding rounds for a lot of these databases, but I chose this particular version of Vani GPT, as we're calling them, is built on Pinecone, which is just a SaaS offering. But there's tons more. The ones on the left are kind of like dedicated vector databases, and the licensing is top and right. But the ones on the right-hand side are kind of, I guess, more traditional databases that we're used to hearing about using in our daily lives that have kind of built support for vector sitting over the top. So this is kind of what the Pinecone interface looks like. We create a database and then we can just start talking. We just talk HTTP over the internet and put these embeddings in and out. The app itself, it's a little JavaScript app. Like I said, about 2,400 KB articles, and effectively just like that diagram showed, we ask it a question, and what we do, because we need to interpret that question, we embed that question. So we ask the model, hey, embed that question, we get those numbers back, and then what we do is we query the database for the most likely candidates in our database, and then we can feed those documents back to the LLM along with our query, and get everything back. And so that was version 1. It's actually only using the top match. Version 2, I've now got a much larger data set. We've moved on from just KB articles. That's around 6,000 data points. We're using a slightly different backend. Just wanted to learn something new. Superbase is a really neat platform for that sort of thing. Langchain has sort of come along. It was already around, but it's really mature now for dealing with these queries. Obviously, in the first version, I'm just making the calls directly to OpenAI and Pinecone. Now there's just nice big wrapping libraries that handle all this stuff really well for you. And yeah, shout out to Langchain. It's a fantastic platform. So yeah, prompting and chat history is built in. We're not going to deep dive into chunk sizes, but at the moment we're just doing one large chunk because all the KB articles conveniently fit into that chunk size that we're allowed into the model. But sometimes you might want to chunk those documents up and then run some overlap, and then it makes it a bit more efficient, but also the answers can be maybe a bit more targeted. But there's a real art to it around the prompting and what size chunks you've got and what data. So there's a lot of experiments from my side running different chunk sizes and things at the moment. And we're also using more than just the top match. I'm using the top 4 documents, feeding those through to OpenAI with my query, and then it's constructing its answer from that. But again, sort of tweaking that a bit. And it streams the tokens in real time. So what that looks like is something like this. So this is Vani GPT. You can see I've already pre-canned a question here. I can just ask Vani a question. It'll buzz away, and you see, nope, they're not supported, blah, blah, blah. And I can click here and go off to the Veeam KB article. But because I've already cleaned up all of the KB articles into Markdown, I just render it straight in the browser because that's kind of neat. And so here's basically the article, and I can ask them another question. And so what's really cool about Vani is, well, the large language models themselves, is you can start asking questions, and depending on the way you ask it, obviously you get slightly different answers back. So I'm getting it to summarize the V3A Red Hat release for me. It has answered it like that if you can bother reading it, but basically it's got a whole bunch of stuff. But you might want to know, what the resolved issues are. So if we paste that in, we'll get a slightly different answer, and it'll just return, hopefully, the basically resolved issues from the KB. So we'll get a completely different answer back. And so you can see now it's just answered just the resolved issues. It hasn't worried about the new functionality or other bits and pieces that might be in those release notes. So you can see it's pretty powerful. I no longer have to read this whole KB article to understand, and you imagine some that are a bit longer, what that is, and I can start interacting with these KB articles. So hence the reason I'm really excited about this sort of thing, because it's pretty neat, particularly when you start building out that data set wider and wider and wider. The level of access the model can have access to is pretty neat. Yeah, and version 2 is in the works. So this is him now. You'll notice I clicked Ask Vani before, it kind of buzzed away, got the answer, and then returned it for us. This is Vani GPT 2, which isn't really finished yet, but it works. So now, as the LLM's giving me answers back, it writes it out like your sort of ChatGPT interface. So now it's streaming the tokens out, and then it will finish when it's finished. And it's got a whole chat history and things. I can start going, cool, that's great, but give it to me in bullet points or whatever it might be. That's it. That's my rabbit hole so far.
Wow, that's really cool.
Wow.
Yeah, that's neat.
Sounds like just the beginning of the rabbit hole.
Yeah.
Yeah, that's it. Like, knew nothing, and now I knew like slightly less than nothing. Like, man, there's some pretty revolutionary stuff going on in this space. It's really neat to follow.
But so the algorithm exists already. So you just gave the data.
All I've really done is write some code, and I've really stood on the shoulders of other giants. But yeah, I mean, we're using a trained model. We're using the GPT 3 or 3.5 model. I can't remember in this case. We can choose. Again, it's a bit of a cost benefit too. Sometimes the lower cost, faster models are okay for the like the workload that you are throwing at it, but other times you might want the grunt and the power of the GPT 4 or 3.5. Sometimes you want a bigger token window, that sort of thing. So yeah, you can kind of pass your context with it. But there's a whole art to like prompting, and I'm sure you've all been onto OpenAI, ChatGPT online and typed something that didn't quite give it the answer you want. So you start giving it slightly different words and building out different sentences and telling it don't put emojis in there and all those sorts of things. And it will give you the answer back. You can even get it to, return it in JSON or a different format, and it will handle that. So there's a real art to prompting, and that's sort of some of the things in particular with 2.0 that I'm playing with is getting the prompting right, because if it's not right, you kind of get, stuff back that's kind of unintended or not optimal. So yeah.
So just so I'm clear, the scoring that the large language model did, that's specifically on the prompt, if you will, what you typed in, right? Or is it actually looking at the document itself to go, okay, this.
So
this
we're actually
document-
just passing the whole document. So the scoring actually happens. So when you ask the question, it embeds that, and then we just do a database lookup basically and go, hey,
Okay.
what's the most similar document or similar documents that match that kind of query?
Okay.
In the first version's case, we just take the top match. So when we ask the vector database and it gives us the results back,
Gotcha.
we get a score. We kind of get a, hey, it's 78% probable that that's a match. So in the first version, we're just taking the top match and then passing the whole document, the whole text, and we're just letting OpenAI basically take the question and the document and go, yeah, that's the answer.
Wow.
Yeah,
Cool.
pretty fun.
Okay. Yeah.
I think this is fabulous because I think, what you're talking about with the prompts is absolutely correct, but you wouldn't be able to get the answers back unless you were a Veeam SME. So you understand the content very, very well. You know what you're looking for, but the way that it was on the web made it impossible to find it. So because you're an SME, you're able to construct those prompts to give back what you need. So I think it's very, very cool.